Hello and welcome to my series on MCAT physics. In all of these videos, we are covering exactly what you need to know to be prepared for MCAT style questions, and in this video, we're going over vectors. If you like these videos, I encourage you to check out my MCAT community. There are typed out explanations and drawings that cover all of the topics that are in this series, plus all of the other high yield CP and BB content.
Vectors are used to show things that have both magnitude and direction. Common things that they're used to show are force, acceleration, velocity, and some other things that commonly have to do with motion or energy. For example, if we have an object right here, we can use a vector and this number line to easily show that we're pushing on the object with a value of 3 newtons because we go from 3 to 6, and this force is only in the horizontal direction due to the direction of that arrow. And that's what we mean by magnitude and direction. One of the most important aspects about vectors is the idea of components. If we look at the vector we drew for the 3 Newton force, it only moves in the horizontal direction on the x-axis, so it only has an x component. If we were to draw another force on this object going from 5 to 2.5, then that force would equal 2.5, and it's only in the y direction, so it only has a y component. So we can say that the x component here is equal to 0, but the y component is equal to 2.5. And for the vector on the left, we can say that the x component is equal to 3, but the y component is equal to 0. Now if we have another force where we start from 6 and we draw all the way down to the object, this vector moves partially in the x direction and some in the y direction. It looks like in the x direction, it goes from about 4.5 to 6, so we could say that the x component is 1.5. The y component looks like it goes from about 6 to 2.5, so the y component is 4.5. What breaking it down in its components allows us to do is analyze these forces only in particular directions. For example, let's say we are wondering what forces are making this object move to the right. And let's assume that this object is resting on a floor that extends this way. Since the object can only move horizontally, given that it's blocked by the floor to move vertically, none of the y components of any of these force vectors are going to affect the object's motion in the x direction. And that's one of the most crucial concepts in all of physics that you have to make sure you understand. All of the y components would just be pushing this object down into the floor, not helping it move to the right. We'll talk a lot more about this when we go over things like force and velocity, but what you would do here is just add up all of the x components for these 3 vectors to figure out the total force moving this object to the right. If you think you conceptually are good with the idea of breaking these vectors down into their components, then now what we need to talk about is finding their components if you're given a missing value. Questions that are asking you to find missing components usually go something like this. What is the total magnitude of a vector with an x component equal to 3 and a y component equal to 2? We can go over to the number line here and sketch this out. So we can start at any number. We just have to draw to the right 3 and then up 2. Then we can draw a connecting arrow between those. So this is the full vector that they're asking about. Sometimes just sketching it out like this will be fine if the question is just asking about what is the direction of this new vector. But if they're asking about an exact value like they're doing here and they want the magnitude, you're going to have to do some easy math and do Pythagorean's theorem, which is just a squared plus b squared equals c squared, with a and b being the 2 sides of the right triangle and c being the hypotenuse. So this one is 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. C squared equals 13, and then a rough rounding, c is probably equal to like 3.5. Sometimes you will be asked to use trig values to find these missing values, but we're going to cover that in a later segment when it's more relevant. The last thing we'll cover is adding and subtracting vectors. Problems like these usually do something like vector A has an x component of 5 and a y component of 3. Vector B has an x component of 3 and a y component of -5. And then they'll say vector A plus vector B gives us vector C, and then ask what are the x and y components of vector C. Let's do this both visually and mathematically. You can start anywhere on the number line, but for vector A, let's just start at 6 and 1. We have to go to the right 5, so we'll draw a line to the right until about 6, and then we have to go up 3, so we'll stop at 9. Vector A is then connecting these two, so that is vector A. Anytime you're adding one vector to another, so we're adding B to A, you're going to start at the end of the first vector listed, and then just draw the next vector. So we go over 3, so we need to stop at about 9, and it's a -5 for y, so we go down 5. So we go from 9 to about 4, and then we draw that final vector, and that is vector B. To draw that final vector, which is vector C, start at the tail of the first one, and then draw a line to the tip of the second vector that you're adding to that first one.
and this is vector C.
Real quick, if we were subtracting b from a, so if this was vector a minus vector b, you would do a lot of the exact same things, but you would just flip the direction of vector b. So you would draw a line that looks more like that, and then vector C would go that direction. So that's how you would draw this out. Now let's do this mathematically. And this is actually quite a bit easier. All you do is add up the x component of each vector and add up the y component of each vector. That gives us 5 plus 3 is equal to 8 for the x, and 3 minus 5 is equal to negative 2 for the y. If we look at what we drew for vector C, we can check this, and it does look like C goes from 1 to 9, which is 8 in the x direction, and it does go from 6 to about 4, which is negative 2 in that y direction. And if we were subtracting vector B from vector A, we would do 5 minus 3 and 3 minus negative 5 to give us final values of 2 and 8. And if you look back at what we quickly sketched for vector C up there by doing subtraction, that does look like we'd be roughly at 8 and 2. And the final thing we have to quickly look at is just multiplying a vector by a constant, which is super simple. Let's stick with vector A and say that the question is saying, what is vector A times 3? All you do is multiply the x component by 3 and then the y component by 3. So that would give you an x component of 15 and a y component of 9. And then you can just sketch that out to see what that final vector would look like.